Colorectal cancer used to be considered a disease of older adults. The standard recommendation was to begin screening at age 50, and for most of medical history, that guidance made sense because the overwhelming majority of cases occurred in people over that age. That is no longer the picture. Rates of colorectal cancer in adults under 50 have been rising sharply for decades, and the medical community has been searching for an explanation. A team of researchers at UC San Diego now believes they may have found a significant piece of the answer, and it comes from inside the gut itself. The finding centers on a toxin called colobactin. It is produced by certain strains of gut bacteria, including specific strains of E. coli, and it has the ability to directly damage the DNA of the cells lining the colon. That DNA damage, the researchers argue, may be setting the stage for colorectal cancer years or even decades before a diagnosis is ever made. The implications of this research extend well beyond the lab, and by the end of this video, you will understand both why this matters and what the science currently says you can do about it. Lyudmila Alexandrov, a professor at UC San Diego and a member of the university's Moores Cancer Center, described the finding in stark terms. Not every environmental factor or behavior we study leaves a mark on the genome, he explained, but colobactin is one that does. Its genetic imprint appears to be strongly associated with colorectal cancers in young adults specifically. What Alexandrov and his team found is that colobactin leaves a distinctive pattern of DNA mutations in colon cells, a kind of molecular fingerprint, and that fingerprint shows up disproportionately in colorectal cancers diagnosed in younger patients. This suggests that the exposure driving those cancers happened early, potentially in childhood, and that the cancer developing decades later is in part the consequence of that early damage. To understand why this matters, it helps to understand what colobactin actually does at the cellular level. The inner lining of the colon is constantly renewing itself. Cells divide, old cells are shed, new cells replace them. Every cell division carries a small risk of a copying error in the DNA. Most of these errors are caught and corrected by the body's repair mechanisms. But colobactin appears to overwhelm those mechanisms by directly attacking the DNA in colon cells, creating breaks and mutations that the normal repair process cannot fully address. Over time, if those mutations accumulate in the right locations on the genome, they can disable the cellular controls that prevent uncontrolled growth, and cancer begins. The prevalence of colobactin-producing bacteria in the population is significant. Microbiome researcher Christian Jobin of the University of Florida has noted that approximately 20 to 30% of adults carry strains of E. coli capable of producing colobactin. That is not a small number. It means that roughly 1 in 4 people has this toxin-producing bacteria present in their gut. Yet not everyone who carries these bacteria develops colorectal cancer, which tells you that colobactin is a contributing factor rather than a definitive cause. The risk is shaped by the overall balance of the gut microbiome, by diet, by inflammation, and by other variables that researchers are still working to understand. One of the most striking observations in the research is geographic. Colobactin-related colorectal cancer is significantly more common in the United States and Western Europe than in Africa and Asia. Jobin has noted that some of the E. coli strains that produce colobactin are influenced by diet, inflammation, and medication exposure. He has also pointed to factors like birth method, breastfeeding practices, antibiotic use in childhood, and early exposure to ultra-processed foods as potential contributors to why colobactin-producing bacteria thrive in Western gut microbiomes more than others. Each of these factors is known to substantially affect the microbiome, and the early colonization of the infant gut in particular may shape the bacterial landscape in ways that persist for decades. Alexandrov made a point that challenges how most people think about cancer causation. He noted that many cancers may originate from microbial or environmental exposures that occur long before diagnosis, and that cancer could potentially be influenced by events in early life, perhaps even the first few years. This is a significant reframe. Most cancer prevention messaging focuses on adult behavior: diet, exercise, alcohol, smoking. The colobactin research suggests that what happens in the gut during infancy and early childhood may be laying the groundwork for cancer risk that does not manifest until middle age or beyond. For parents, the implications are immediate. Building a healthy gut microbiome in infants starts before any solid food is introduced. Breastfeeding is one of the most effective tools available because breast milk contains beneficial bacteria, prebiotics that feed those bacteria, and immune compounds that shape the early microbial environment of the gut in ways that formula cannot fully replicate. Skin-to-skin contact between infant and caregiver also transfers bacteria from adult skin to the infant, contributing to microbial diversity in the early gut. Probiotic fortified formula is another option for parents who cannot breastfeed, and avoiding non-essential antibiotics in infancy and early childhood matters significantly because antibiotics do not discriminate between harmful and beneficial bacteria. Stanford Medicine puts it plainly: antibiotics can cure bacterial infections, but they kill off beneficial gut bacteria at the same time, and they should be used only when genuinely necessary, rather than for viral illnesses where they have no effect. For adults, the protective strategies align with what the broader gut health research already supports, but understanding the colobactin connection gives them added urgency. Probiotic-rich foods such as yogurt, kefir, sauerkraut, kimchi, and genuine fermented sourdough introduce beneficial bacterial populations that compete with harmful strains like colobactin-producing E. coli. These beneficial bacteria produce acids that create an environment less hospitable to harmful strains and help modulate the inflammation that allows those strains to flourish. Fiber is the other major lever available, and the evidence behind it is direct. Researchers at the University of Cambridge have shown that fiber may protect against a range of harmful bacteria, including E. coli, and that feeding beneficial gut bacteria through dietary fiber boosts the body's defenses against infection and microbial imbalance. A study examining the relationship between diet and colobactin specifically found that eating fiber led to lower levels of E. coli and less DNA damage in colon cells. The same study found that mice on low-carbohydrate diets had thinner layers of the protective mucus lining the digestive tract, which allowed more colobactin to reach colon cells directly. Fiber feeds the bacteria that produce the compounds that maintain that mucus layer. Getting 3 to 5 grams of prebiotic fiber daily has been shown to produce meaningful benefits for gut bacterial balance, and that target is reachable through foods like oats, bananas, asparagus, garlic, and bell peppers. Hydration is another factor with a direct mechanism. Adequate water intake supports the production of the mucus layer that lines and protects the digestive tract. Women need around 11.5 cups of water daily, and men around 15.5, according to the Mayo Clinic. That mucus layer is the physical barrier between the contents of the gut, including bacteria and their toxins, and the colon cells those toxins can damage. Exercise rounds out the protective picture. Research has shown that sedentary individuals have fewer health-promoting bacterial species in their gut compared to active individuals. The good news is that the benefit does not require extreme effort. The federally recommended 150 minutes of moderate exercise per week, about 30 minutes on 5 days, is enough to produce measurable positive changes in gut microbiome composition, according to research published in 2023. More than 158,000 new colorectal cancer cases are expected this year in the United States alone, with over 55,000 deaths. The rise in young adult cases makes this a problem that can no longer be framed as something that happens to older people. The colobactin research is still developing, and researchers themselves are careful to note that more investigation is needed. But the direction of the evidence points clearly toward the gut microbiome as a central piece of the colorectal cancer puzzle, and toward diet, early life exposures, and lifestyle as the most accessible tools available to shift that risk. If someone you know has been paying attention to this rise in young adult colorectal cancer and does not know about the colobactin connection, this video is worth their time. The channel